All right, welcome to week eight. Week eight on sequences and series. We're going to start chapter 5. We're actually going to do 5A, 5B, and 5C today. These are going to be video, and then there will be a series of problems in the book or Delta Math. I haven't decided which one yet for you guys to work on for these. And so let's go ahead and get started. So, number sequences. A number sequence is nothing more than this idea of an ordered list of numbers defined by a rule. So the numbers in a sequence are often called the terms of the sequence. So our general goal for this unit is to resume share, sorry. Our general goal of this unit is to actually recognize a pattern in a set of numbers. We also need to be able to describe the pattern in words, and then we also need to be able to continue the pattern. So that's going to be our overall goal as we move through this unit. So let's take the following. We've got some poker chips here, and we've got them in piles. We've got a pile that starts with 3, actually 2. I can't count, so I apologize. So if we were to describe this number sequence, what could we do? There's a number of different ways. So how could we describe this number sequence? Great. We could just start by listing the terms. We could describe the number sequence by listing the terms. So in this case, we would go 2, 5, 8, 11, 14. Okay. We could describe this in words. How would we describe this in words? Yeah, we're going to start with 2 chips and increase by 3 chips each time. Okay. We could also write a formula to describe this. So we're going to represent the nth term So in our case, we are going to say 2 plus 3 times n minus 1. We'll talk more about what that actually is in a few minutes, but that's the general term. So we could find the 10th pile of chips or the 20th pile of chips, and we could tell you exactly how many chips are in it. We could also graph this. Now graphing it, if we create a graph, we're going to put the number n here, and we're going to have the number of chips here. So we start with 1 pile, 2 piles, 3 piles, 4, 5. We would say, okay, 2, 4, 6, 8, 10, 12, 14, 16. So we could put the number of chips there. So 1 pile, we have 2 chips. 2 piles, we had 5 chips, which is halfway between 4 and 6. 3 piles, we would have 11, so halfway between 10 and 12. Actually, I forgot 8, didn't I? You guys are supposed to tell me that. So 3 piles, we would have 8. There is a bug flying around my head again. 3 piles, we have 8. 4, we would have 11. 5, we would have 14. And no, I did not graph that so well. But we get the basic idea that we would have the n value on the x-axis and the number of chips on the y-axis. So we would also represent each term of a sequence by a dot. These values must be integers, and then our u sub n value would go up here. So we're going to talk about all of these different ways. The listing the terms and the words, that's going to kind of be on you, but we will spend quite a bit of time talking about this nth term and the graph. So we'll be actually working on those. So, notes piece today. All right, the general term of a sequence or the nth term. Okay, we're going to write it with a symbol with a subscript. The subscript is going to tell us the number of the term. So for us, we would use u sub n as our nth term. Okay, u sub n represents the sequence that can be generated by using u sub n as the nth term. Unless we otherwise state it, the initial or the first term of the sequence will always be u sub 1. This will be the first term of the sequence. So we could have un could be the sequence u1, u2, u3, u4, ... all the way up till u sub n. So that's just our notation for talking about sequences. So that subscript just tells us which term of the sequence we're actually looking at, which is actually something really important to think about because that subscript doesn't have any mathematical connotation. The only connotation that we have with that is to tell us which of the sequence, which term in the sequence we're actually looking at. Okay, sometimes we'll start at u sub 0, but this is usually if n represents the number of time periods after, like say the start of an experiment or after an investment experiment or after an investment, we might say u sub 0. So maybe we say 1990 is the initial value and every year thereafter is another term in the sequence. So like 1991 would be year 1, whereas 1990 would be year 0. So like 1990 would be the u0 term, and then 1991 would be u sub 1. So thinking about it like that. So hopefully that makes sense. So 5A is all about just about sequences, like identifying what kind of sequence it is. Can you find the mathematical pattern, whether it's addition, subtraction, multiplication, division? There are a whole different types of patterns that we can look at, and that's what 5A is talking about. Now we get into the following, which are arithmetic sequences. And this is where, one, we tie back into Algebra 1, because I do know arithmetic sequences are taught in Algebra 1. But an arithmetic sequence is a specific type of sequence. We're going to talk about 2 specific types of sequence today. We're going to talk about arithmetic ones, and we're going to also talk about geometric ones. But an arithmetic sequence is a sequence of numbers where each term differs from the previous one by a fixed number. That number is called the common difference. You might refer to that as the slope. But this idea of a common difference. So a sequence is arithmetic. So we have an arithmetic sequence if and only if, so that backwards and forwards arrow means it goes both directions, if u sub n plus 1 minus u sub n, so the larger or the further term minus the closer term, is equal to some common difference d for all n that are an element of the positive integers. So positive integers are 1, 2, 3, 4, and so on, okay? The general term for an arithmetic sequence is u sub n equals our initial term plus n minus 1 times the common difference. So if we actually translate that into algebra 1, u sub 1 is kind of like your y-intercept. But because we're not starting at 0, since we're starting at 1, notice what did we need to do with our n term? We had to take away 1. Whereas normally it's y equals mx plus b. In this case, it's not. It's n minus 1 times d, d being the slope of the line. So we do need to be careful about that, but that's going to be our general term. That's going to allow us to find any value in the sequence, okay? So I think it's always a lot easier to understand these if we look at some examples. So of course, I did actually pick one of the harder ones to start with, one of the ones that doesn't kind of look quite as nice because it's a little more algebraic. But notice the terms are a plus d, a plus 2d, a plus 3d. So step 1, they want us to find u sub 1 and d. So u sub 1 is easy, it's given, it's just the first term. Okay, now we need to calculate d, what the common difference is. Now some of us may look at this right away and say, hey PK, I can see what d is just by identifying those different pieces. But let's go ahead and actually, let's do some math with it. So to find d, we can take a plus d term, subtract the term in front of it. And if we do that, we end up with d as our common difference. Let's try another one. We could take a plus 2d and subtract a plus d, which would give us a plus 2d minus a minus, that's a d, minus d. A's cancel. 2d minus d is also d. So we can identify that our common difference is actually just d is equal to d. So then what's our general form? Absolutely, u sub n is u1, so go back up, it's u1, u1 is a plus n minus 1, that part doesn't change. What's our common difference that we found? Absolutely, it's just that. So if I want u sub 15, I just substitute a plus 15 minus 1 times d is a plus 14d. So our 15th term is a plus 14d, okay? All right, here's another sequence. Consider the sequence 83 or 87, 83, 79, 75, 71. Does it appear, first of all, to be arithmetic? Is it linked by a common difference, whether that difference is addition or that difference is subtraction? You're right. It is definitely appearing to be arithmetic. Now, IB says show that. They don't always ask you to prove something, but they often ask you to show something. So if I want to show that the sequence is arithmetic, I need to use all of the numbers that are involved there. So I take the larger term, 83, and subtract 87. Verify that that is equal to -4. But I also need to do 79 minus 83, which is equal to -4. And then 75 minus 79 equals -4. And 71 minus 75 equals -4. So all of the common differences are -4. Therefore, the sequence is arithmetic. Okay, so part B, general term. So we take our U1. U sub n is U1. What is U1? Yep, it's 87 plus n minus 1 times -4. Now I do like to do some algebra simplification just because that makes life better. I'm going to put -4 times n minus 1. We can leave it like that. That's absolutely fine. All right, let's find the 40th term. 40th term is going to be u sub 40 equals 87 minus 4 times 40 minus 1, or 87 minus 4 times 39. I had a calculator here today. Look at my wall. Oh, found my calculator. Oh, by the way, today is class color day. I couldn't decide on which class to support, so I went with my tie-dye shirt and my tie-dye shoes, and I'll just support all of you because I love all of you. Sophomores, juniors, seniors, and even the little baby freshmen that I have in geometry. And I'm doing that while I'm stalling for time. I got U40 is equal to negative 69. Okay. Now, again, what should you guys probably be doing while you're doing this? Yes, press pause, try the problem, and then verify your answer. All right, part D. Which term of the sequence is negative 297? Well, I know negative 297 is that term that I'm looking for. So I'm going to substitute that in, and minus 1. So now it's just an algebra 1 problem that I need to actually solve. So if I subtract 87, negative 297 minus 87, so negative 384 equals negative 4 times n minus 1. I'm going to divide both sides by negative 4. 96 equals n minus 1. Add 1 to both sides. N is equal to 97. So the 97th term is going to give us negative 297. Okay. Awesome. Questions so far? Good. Let's try a harder one. I want to find K, but I know that these are consecutive arithmetic terms. So what do I know? I know that if I subtract 2K minus 1 minus K, that should be the same as 13 minus 2K minus 1. Why? Because we're told that they're arithmetic. We know the difference between both of them is equal to D. So now that we have that, we've got an algebra 1 problem that we can actually set up and solve, right? So 2K minus K is K minus 1 equals 12 minus 2K. 3K equals, what, 13? And K is equal to 13/3, provided I did my algebra 1 correctly. You can check it. All right, last arithmetic one. At the start of the dry season, Yafia's 3,000-liter water tank is full. She uses 183 liters of water each day to water her garden. Find the amount of water left in the tank after 1, 2, 3, and 4 weeks. So should we start with 3,000? So after 1 week, we're going to take away what? Minus 183. So that gives us 2817. 2634. So this is after 1 week. This is after 2 weeks. After 3 weeks, we have 2451. And after 4 weeks, we have 2268. Explain when the amount of water left in the tank after n weeks forms an arithmetic sequence. Okay. When will her tank run out of water? I'm actually going to put in, I'm going to put in a little Schoology assessment quiz. I want you to answer those 2 questions in that quiz. Okay? All right, now it's time for geometric sequences. A geometric sequence differs from an arithmetic sequence because each term is obtained by multiplying by the same non-zero number as opposed to adding or subtracting, okay? So we get a geometric sequence. It is a geometric sequence if and only if, so the arrow is going both ways, u sub n plus 1 divided by u sub n is equal to a common ratio for all n are an element of the positive integers again. Okay? So our general term is u sub 1. We get that by taking u1 and multiplying it by the common ratio to the power of n minus 1. Okay? For each of these geometric sequences, state u1 and r, and then find the formula for the general term u sub n, and find the nth term of the sequence. We're actually going to do this just for letter C. I accidentally copied 2. So u1 is 512. How do I get from 512 to 256? So I'm going to find r by taking 256 and dividing it by 512. That's the 1/2. Now let's just verify. Let's do 128 over 256. Yep, that's also 1/2. So that means r is equal to 1/2. So the general term, u sub n equals, what did we say? u1 times r. So u1 is 512 times r of 1/2 to the n minus 1. What does that look like from algebra 1? You're right if you said it looked like an exponential equation. It is an exponential function. Just dropped water all over. It looks like an exponential. All right, so now we just need to find the 9th term. So u9 is 512 times 1/2 to the 9 minus 1. So 0.5 to the power of 8 times 512, I got 2. Thankfully, calculators are in existence and you guys can use them for everything. All right, let's try another one. What? Show that. There we got that. Prove again. Show that. Show that the sequence is geometric. So I'm going to just do some division. I'm going to do -6 divided by 8. I'm going to do 4.5 divided by -6. And I'm going to do -3.375 divided by 4.5. And those should, if it is geometric, all be the same. So -6 divided by 8, I got -0.75. 4.5 divided by -6, -0.75, it's appearing. And then -3.375 divided by 4.5, also -0.75. So is it geometric? Yes. un plus 1 divided by un is equal to -0.75 for all shown terms. Therefore, the sequence is geometric. So now let's write u sub n. What's u1? 8. What's my common ratio? -0.75 to the n minus first. So now if I want u10, just going to do -0.75 to the power of 10 minus 1, which is just 9. So -0.75 to the power of 9 times 8, because it says leave it as a decimal. I got -0.60068. And make sure I have enough sig figs, so I went out a few more. Questions? Bueller? All right, let's try another one. We're going to do letter C. So find K, given that the following consecutive terms are a geometric sequence. So we're going to use that same idea that we did in that previous arithmetic one, where I'm going to say K divided by 7 should be equal to 28 over K. Now it's an algebra 1 problem. Cross multiply, K squared, 7 times 28 It's 196. Ah, sweet, I can take the square root of that. Square root both sides. K is equal to square root of 196. I think it's 14. Okay. Questions? Now, why isn't it negative 14? Could it be negative 14? Could be. Because what if I went 7, then I had negative 14? The next one would be positive 28. The next one would be negative 56. So it would fit the pattern, wouldn't it? What's our common ratio? It's either 2 or negative 2. All right. Questions? All right. Last question. We're going to do letter, let's do D. Let's make our lives a little more challenging. Let's do letter D. All right, so find the general term of the sequence. Noticing that they're not sequential, are they? We went from U3 to U7. So if we go from U3 to U7, we need to maybe do a little bit of work. So how do we get U3? U3 is U2 times R, correct? All right, I'm going to move this down just a bit. U3 is U2 times R. And U2 is U1 times R. And then we started with U1, whatever that U1 is. So U1 times R gives you U2. U2 times R gives you U3. All right. And then let's see, U4 is U3 times R. U5 is U4 times R. U6 is U5 times R. And U7 is U6 times R. But we kind of want to base everything off of U1. So U1, U2 could be replaced with U1 R times R, which is U1 R squared. Wait a second. U3 is U1 R squared times R, which is U1 R cubed. Are we seeing a pattern? We're going to put U cubed, U1 R cubed in for U4 times R. And now it's U1 R to the 4th is U5. Can we skip? And this will be U1 R to the 5th. This will be U1 R to the 6th. That's kind of cool. Are we seeing kind of that general form? Maybe. Let's do a little bit of substitution. 5 is equal to U3, which is U1 times R cubed. And 7, U7, 5/4 is equal to U1 R to the 6th. So far, so good, right? They both have a U1. I wonder if we could like do something with that. What if I did U1 R to the 6th divided by U1 R to the 3rd? Do the same thing over here. 5/4 divided by 5. The U1s cancel, and we're left with R cubed. What's 5/4 divided by 5? I don't know, 5 divided by 4 divided by 5. Oh, it's just a 4th, isn't it? Wait a second, we can solve that. We can take the cube root. R is equal to the cube root of 1/4. Making sure I didn't screw up. I did. This R should have been to what power? Because it's U3, U3, and U7. Which means if this is a 2, this means this is no longer a 3, it's a 4. So we actually want to take the 4th root. So we got our R value. Doesn't that feel right? All right, so moving on. Now we got this R equals 4th root of 1/4. Well, I'm going to change that to 2 squared. So now I'm going to do a little algebra magic, which you're not going to have to do that algebra magic on your paper. But I'm going to keep the 2 squared as 2 to the negative 2. But I'm going to raise that to the 1/4 power because that's the whole radical piece. Which, if we then multiply those, we end up with 2 to the negative 1/2. Which means R is 1 over the square root of 2. And it's going to be positive or negative. So we do need to remember that it'll be positive or negative. Now, before you panic about that, let's just go with that. But U1 equals, well, we don't know U1, but we know U3. We know U3 is equal to U1 times R squared, right? So let's substitute in 5 equals U1 because that's what we're looking for. We'll put 1 over the square root of 2 quantity squared. Well, that's 5 equals U1 times 1/2 because square root of 2 quantity squared is 2. We're going to multiply both sides by 2. U1 is equal to 10. So our general term, U sub n, is equal to 10 times 1 over root 2 to the n minus 1. And UN is equal to 10 times negative 1 over root 2 to the n minus 1. Both of those are going to be completely acceptable. So excuse the little algebra magic with changing your radicals, but that process is what I'm actually looking for. Can we identify where those things change? So again, go back. You will have a short little quiz that's actually going to ask you to answer those 2 questions. Explain why the amount of water left in the tank is, after n weeks, it forms an arithmetic sequence. And then I'm going to ask you to find out when her tank runs out of water. So again, I will post those on Schoology into a little quiz to indicate that you've actually watched the video. So talk to you later. Bye.